Hello everyone and welcome to the Autodesk DevCon conference AI for a Sustainable Built World, Ethical and Legal Perspectives. My name is Candice Assin and I am the CEO of DB Lab, a French company specialized in BIM data management. Before we dive into the topic, let's start with a few questions. How do we make a right decision? What guides a right choice? What criteria, measurable objectives like energy reduction, cost efficiency? What about subjectivity and values? Every decision or choice reflects human priorities and context. Second question, are we responsible for something we can't explain? As AI systems grow more opaque, do we still bear full responsibility for their outcomes? And then, to finish, is plastic good? A simple material question reminding us that sustainability isn't black and white. Today's benefits can become tomorrow's burdens. Now, let's look at our agenda. Keeping in mind we are navigating complexity and uncertainty. First, we will tackle the sustainability challenge. Understand how scale in time and space affect our decision. Next, we'll explore ethical considerations. Who gains, who lose when AI defines optimization goals and why transparency matters. Finally, we'll cover legal frameworks, how regulations can catch up with AI, who is accountable for AI-driven outcomes, and how to craft adaptable rules. With this roadmap, we build a holistic view before diving deeper into each pillar. Let's begin with the real sustainability challenge. Sustainability is not a challenge. It's a balancing act between cost, time, and quality. Cost. Short-term savings through AI may look appealing after all. Buildings accounts for 30% of global energy use, but using cheaper materials can backfire. Time. Accelerating schedules with AI-driven planning speeds delivery. Yet, if we ignore life cycle carbon emissions, we lock in environmental harm for decades. These aren't abstract numbers. They affect the air we breathe. Quality. Durability alone doesn't equal sustainability. A structure built to last a century may fail to meet social needs if its design ignores people's well-being. These decisions don't just move needles on the spreadsheet. They shape lives and our planet's future. How can we make sure our AI actually supports sustainability? It doesn't tip the balance against our long-term well-being. We often think of sustainability in environmental terms, but it really stands on three pillars: environmental, economic, and social. Environmental. Is our solution truly eco-friendly? We must slash carbon footprints, favor recyclable materials, and conserve resources at every step. Economic. Is it viable over the long haul? That means looking beyond upfront costs to full life cycle expenses, ensuring resilience to market swings and delivering real value over time. Social. Is it fair and inclusive? True sustainability integrates communities, creates quality jobs, guarantees safe working conditions, and ensures accessibility and well-being for everyone. But these pillars don't stand alone. They play out across time and space. We often pick the easiest path because we have the data and can see immediate results. Yet, optimizing one facility now without considering future impacts or larger scales risks undermining our cities and communities down the road. The strongest argument for embedding AIs is shifting from an optimization system to a resilience system focused. Let's compare two approaches, efficiency versus resilience, to properly rethink AI's role. For timescale, efficiency is about immediate impact, rapid optimization. Resilience, long-term impact, future-proofing decision. Decision focus, efficiency asks, what's the best choice today? Resilience asks, what will remain viable over time? Approach. Efficiency fixes problems reactively. Resilience anticipates risks and adapts proactively. Sustainability impact. Efficiency may reinforce existing patterns and ignore long-term consequences. Resilience balances efficiency with environmental and social factors. Risk management. Efficiency optimizes based on past data and may struggle with unknowns. Resilience uses scenario modeling to navigate uncertainty. We see how moving from AI-driven efficiency to AI-driven resilience reframes our approach. But this raises a deeper question. Is AI itself a problem? AI holds up a mirror, revealing risk in our own system and in the technology we build. Let's walk through two sets of challenges. First, AI's impact on human systems. Protection of fundamental rights. Unchecked AI can infringe privacy, freedom of expression, and due process. Critical activities. Errors in healthcare, finance, or infrastructure, AI can cost lives. Manipulation and disinformation. AI-generated content can spread falsehoods at scale. Cognitive autonomy. Over-automation may de-skill workers and hurt individual judgment. Accelerated decision. Speed can amplify mistakes. And lack of contextual awareness. AI often misses cultural, social, and ethical nuances humans grasp naturally. What about trusting AI? Bias, and algorithmic discrimination. Historic data can lock in inequality. Lack of transparency and explainability. When we can see how decisions are made, we can't trust them. reliability, rare cases can cause unexpected failures. User trust, lack of understanding styles adoption, and envious misuse. Data limitations, incomplete or low quality data leads to flawed outputs. And accountability and responsibility. It's unclear who, developer, operator, or organization takes the blame when AI errs. These issues aren't hypothetical. They show where our human system needs strengthening and where AI demands careful governance. Only by facing these reflections can we build technology that truly serves us. So, what can we do? Ethics and law are two paths we must explore. To begin with the ethical perspectives, I like to keep in mind Socrates' reminder, I know that I know nothing. In ethics, humility is our starting point. But what is ethics and what matters with AI? Ethics is the philosophical study of the best way to live and act. It asks, what is right and responsible in each context? Ethics relate with other concepts like morality, beliefs, and culture. Our sense of right comes from shared values, religion, social norms, personal conviction. I give you keys for applying ethics to AI. You have to know that there is no formal system of moral seeking. We can't reduce ethics to code. Also, there is no ethics without context. What's right in one situation may be wrong in another. AI system bias comes from chasing efficiency metrics without guardrails. AI lacks emotional intelligence. Machines don't feel empathy, so they miss the human side of ethical choices. With these ideas in mind, we can build AI that respects value, adapts to different contexts, and guards against bias. After that, what we can do? Now we have to formalize ethics in AI. And to turn ethical principle into action, we need a dynamic framework grounded in core values, fairness and non-discrimination. AI must not reinforce historical inequalities. We build algorithms to treat everyone equitable and check for disparate impacts before deployment. Transparency and explainability. Every AI decision should be clear. We surface explanation so users and regulators understand why a recommendation was made. Privacy and data protection. AI must handle personal data responsibly, minimizing collection, anonymizing when possible, and fully complying with privacy laws. Accountability and responsibility. When AI errs, someone must be accountable. We define clear ownership of outcomes. And robustness and security, AI systems must be reliable and resilient. resistant to failures, cyber attacks, and adversarial inputs. We test aggressively to uncover and fix vulnerabilities. In practice, we rely on institutional standards, industry initiative, and technical safeguards like algorithm audits and responsible AI certifications to keep this framework alive and evolving. Now, let's look how to put ethics into practice across the AI life cycle. First, apply ethics in AI development. During the design phase, identify risks and societal impacts early on. Ask, who might be harmed before writing a single line of code? Data collection. Ensure diversity and avoid systemic bias. Collect representative samples and scrub historical prejudices. AI models. Make algorithms interpretable and adaptable. Build in explainability hooks and update mechanism. Deployment and monitoring. Continuously check that outcomes align with ethical goals. Set up real-time alerts for bugs or failures. And for some strategy for reinforcing ethical AI, you have to integrate ethical consideration from the ground up, not as an afterthought. Evaluate algorithmic impact both before launch and during operation. Treat audits like safety checks. And engage domain experts, end users, and policymakers throughout development to surface hidden concerns and build trust. By weaving these steps and strategies into our process, we make ethics a living practice, not just a box to tick. Now, let's look at how we guarantee those ethics in practice. Guaranteeing AI ethics means clear responsibility and strong safeguards. Who is responsible for AI ethics? Every stakeholder, developer, regulators, and users has a role to play, and we must clearly define and share responsibility across the ecosystem. Which mechanism to ensure ethical AI? This responsibility rely on normative rules, governance bodies, and transparency requirements, with effective adoption being essential and can be enforced and audited. With ethics covered, let's shift our focus to the legal perspective. Around the world, three very different AI regulatory models are emerging. In Europe, the AI Act takes a precautionary, risk-based stance. It sorts AI into 4 risk levels, from minimal to unacceptable, and imposes strict requirements on transparency, explainability, and governance. Organizations must embed these controls from day one or face significant penalties. In the United States, regulation is market-driven and sectoral. Rules are set per industry, while the NIST AI risk management frameworks promotes self-regulation. The priority is innovation and competitiveness, with recent executive orders pushing for more transparency in advanced models. In China, AI is a strategic national asset under tight state control. The government proactively regulates algorithm and content to meet national objectives, balancing a rapid development with stricter oversight. Each of these approaches mirror its region's culture and legal tradition. But the central question is that AI carries its own risk and responsibility, ones that will touch and transform every legal system. But why AI challenge liability? First, autonomy. When AI decides on its own, who's accountable? And how do we determine the right level of autonomy to grant it? Opacity. Black box algorithms hide how decisions are made, making liability murky. Error propagation. One mistake can cascade through systems, multiplying harm. Learning and evolution. AI changes over time. Liability can just fall on the original developer. These threats break traditional liability models and demand new legal thinking. Consider these questions. Does decision-making or action belong to a single person or organization? Are we entering the golden age of shared responsibility and automated compensation? But these challenges about responsibility risks are quite general. To manage AI in real-world projects, contracts are our first line of defense. And we can fortify key clauses like collaboration framework. We have to clearly define roles and responsibility between AI provider and user, no gray zone. About objectives and intention, spell out the AI's purpose so it can be misused or repurposed. Intended use, set boundaries. Is the system fully autonomous or only advisory? Data statute. Clarify who owns and controls training and operational data. Trade secrets protection. Lock down sensitive business information used in AI learning. Intellectual property. Decide who owns AI-generated outputs, be it optimized design or creative content. Liability. Establish who's on the hook if AI causes errors, bias, or damages. And you can add AI-specific clauses in your contract, especially transparency guarantee. Require disclosure of AI functionalities, training datasets, algorithmic logic, and known biases. Monitoring and compliance. Build in audit rights and supervision processes to track AI performance and enforce contractual promise. With that, you turn contracts into living tools that govern AI behavior allocate risk, and protect all parties. But beyond contract, AI is reshaping how we practice law, especially around evidence and fairness. Protecting fact in an AI world. As AI generates and processes data at machine speed, we need proactive methods to capture, verify, and preserve evidence before it's altered or lost. Capturing context. The missing piece in AI decision making. AI logs raw data, but often omits the human context, intent, negotiation. We must develop new protocols to record and present that context. Good faith and fair dealing. Traditional doctrines assume human judgment. We need to redefine what good faith means when an algorithm participates. How do we ensure fairness when decisions happen in milliseconds? And I like this question because I think this question must drive our legal innovation. How can justice keep up with the speed of technology? So, this presentation is coming to an end. And to conclude, I leave you with these words. AI is not an independent force. It challenges us to ask the right questions, and that's good news. Its impact will reflect our decision, so we have to take our responsibility. Thank you.